All right, so there's our view from our camera. What we have is a DSLR camera attached to a small telescope that's taking images every few seconds. So we're going to try to adjust this as the eclipse gets more total to be able to see the red part. We wanted you to be able to see a little bit of the features on the moon. Our eyes are much better at our eyes have a logarithmic response, so they can see bright and faint at the same time much better than cameras can. If you have questions, please go ahead and put them in the chat and my colleagues will answer them. We'll have totality in about 50 minutes, maximum totality in about an hour. So as you've probably heard the term that this is a supermoon. A supermoon happens when the moon in its orbit is closer to Earth. The moon's orbit is not a perfect circle, it's an ellipse, and there are times when it's a little bit closer and a little bit further, plus or minus 7%, so a total difference of about 14% from the closest to the furthest. And so the size actually appears noticeably larger to us when the moon is closer in its orbit. And actually, the closest approach is called perigee, and that was yesterday or so. So we're actually at a very super moon. We'll have another super moon next month, but it won't be quite as super as this month's. So we're lucky to have an eclipse during a super moon. It's also called the flower moon. That's just for the full moon that's in the month of May. No surprise, because April showers bring May flowers, and that's where the name comes from. For those of us here in Honolulu, we have a double whammy. Tonight we have, or this morning, we have the total eclipse that's happening right now. And then noontime in the day, we have what's called Lahaina noon. In the tropics, there's 2 months where there comes a day when the sun is directly overhead. And so things that are on the ground like poles, lampposts, they cast no shadows. It actually looks quite strange. So today at 12:29 in the afternoon, we will have Lahaina noon. So we'll go out and take some pictures, and it looks like it's a CGI shot because parking meters and things like that will have no shadows, and it looks pretty strange. So that's kind of neat to have these two happening one after the other. If you're on Hawaii Island, Lahaina noon was a few days ago. We're actually observing the moon from St. Louis Heights near the University of Hawaii in Manoa on Oahu. Since it's the moon, we don't need to go to a particularly dark spot, and we need internet access. So we're just doing someplace convenient where we have power and internet. If you hang out and you're in Hawaii, if you hang out till totality and you have a clear view of the eastern sky, then you'll see Saturn and Jupiter rising in the east. Jupiter will be a little brighter, rising after Saturn. and we'll see how copperish or reddish the moon gets. The term blood moon that everyone uses now is actually relatively new coinage, because there was a series of lunar eclipses close in time that some people claimed was related to some mythology, that was related to some blood thing. And so that term has become popular now, but it was not used in the past. And the moon doesn't always turn coppery or red during an eclipse. It depends on how much cloud cover there is around the Earth and on how much dust there is in Earth's atmosphere. That reddish color comes from the sunlight that passes through Earth's atmosphere and gets refracted around Earth, and then it's what illuminates the moon. Where the moon will be in Earth's shadow, but there's some sunlight that passes through the atmosphere, it's bent through the atmosphere, and lands on the moon. The blue light gets scattered, so that doesn't end up on the moon, but the red light does make it there and can cast that coppery color. But if there's a lot of cloud cover, then that red light can't make it through and on its way to the moon. You don't need a special telescope or anything to see the eclipse. Of course, you can go outside and see it with your naked eye if you're someplace with clear skies and that is actually facing the eclipse. This eclipse, Hawaii has a really nice view. We're catching it when the moon is relatively high in the sky. There'll be another eclipse in November that is an almost complete eclipse. It's going to be something like 96 or 98%, and we'll see that one here in Hawaii as well. So someone asked if what's a lunar eclipse like during the day? You can't have a lunar eclipse during the day. You get solar eclipses during the day because you have to have, if the sun is up, then you cannot be casting Earth's shadow onto the moon. So in the daytime, we get, if you have the right alignment, you get a solar eclipse. Solar eclipses last much shorter than a lunar eclipse because the shadow of the moon on the Earth is quite small as opposed to the shadow of the Earth on the moon. The shadow of the Earth is much larger than the angular size of the moon, so it takes a while for the moon to pass through Earth's shadow. Whereas during a solar eclipse, you have the small shadow of the moon being cast on the Earth, and as the sun moves, that shadow's position changes, so totality of a solar eclipse lasts anywhere from a minute or two to about 7 minutes or so. Whereas lunar eclipse, this one will have almost 15 minutes of totality. If you have questions, please go ahead and post them in the YouTube chat, and myself or one of my colleagues will answer them. I can answer on audio. Some of them may be answering by typing into the chat. So my colleague, Zach Claytor, he's one of our graduate students at the University of Hawaii Institute for Astronomy, is helping answer questions. Carolyn Kaichi, our outreach officer on Hawaii Island. I got to give a big credit to Alex Zierba, who is here running the telescope. He is not a professional astronomer. He's an amateur astronomer who's kindly lending us his expertise and equipment to set this up and run this tonight. And he helped us with the conjunction back in 2020 as well. So someone asked, it's not red. That's because it's not totality yet. So we still have regular sunlight just hitting the moon. So once we're in a total eclipse, we'll only have the light passing through Earth's atmosphere, and then we should be able to see the reddish color better. So if you want to know if you can see an eclipse in your area, I highly recommend a website called timeanddate.com, and you can just put in your city and it shows you where the eclipse will be viewable. So this eclipse totality happens over the Pacific. You cannot see it in Texas, for instance. In Texas, you would get a partial eclipse. So some people in Australia can see it, and many of the island nations in the Pacific, but the mainland US does not get totality during this eclipse. But timeanddate.com or space.com, NASA's websites, they all provide information on eclipses. And you can put in what city you're in or what country you're in, and it will show you what are the upcoming eclipses. So the partial lunar eclipse that's coming in November of this year, on the evening of November 18th to 19th, that will be almost total, something like 96%, and that will be visible through much of the continental United States as well as the Pacific, including here in Hawaii. So for the person in Texas, you'll get a very close to total eclipse on night of November 18th to the morning of the 19th. So someone asked in Texas, when will you see it for the November eclipse? The maximum happens November 19th at 3 in the morning your time. So drink lots of coffee. And that's going to be 97% eclipse is what you'll see. So you probably won't see it turning copper because even with a little bit of sunlight, that's enough to overwhelm that coppery color. Oh, someone in Australia is joining us in watching. Yes, this eclipse is visible there. Not quite all of Australia gets 100% of this eclipse. The easternmost parts only get most of it. I'm sorry, the westernmost parts. So if you're out and looking at the sky here in Hawaii, for instance, you might see a bright star not too far away from the moon in the same part of the sky. That is Arcturus. And for those in Hawaii, the Hawaiian name for that star is Hokulea. You might know the name Hokulea as the voyaging canoe that has helped revive Polynesian navigation, and the Hokulea and its sister ship Hikeanalia are actually out doing training sailings right now. I think they're on their way to Maui from Hawaii Island. Someone mentioned they're viewing in California. In California, you don't get totality for this eclipse, so you won't see totality anyway. So this is the best view you're going to get is watching it online from somewhere. Yeah, Ohio only got a partial eclipse as well. But all of you, California, even though I think even Ohio will see the November almost total eclipse. There's nothing special about us here in Hawaii seeing it. It just so happens that our part of the Earth is rotated away from the sun during the alignment that gives us the eclipse. The reason we don't get eclipses every month is that the moon's orbit around the Earth is tilted relative to Earth's orbit around the sun. So you have to get a perfect alignment between the sun, the moon, and the Earth all lined up in a plane to get an eclipse. And because the moon's orbit is tilted relative to Earth's orbit, it's kind of like two hula hoops, and you have to have them intersecting just when the sun, Earth, and moon are lined up. And that's the only times you can get solar and lunar eclipses. And if you're thinking of traveling, Hawaii is doing pretty well with COVID right now. We actually just dropped our outdoor mask mandate today. However, if you want to come here, there's no rental cars available, so that makes it a bit of a challenge. And thinking of Hokulea, yep, so one of my colleagues has put in that Hokulea means star of gladness. We are quite sad, however, one of the master navigators from the Polynesian Voyaging Society, Kalapa Babayan, passed away recently. And actually, Hokulea, the voyaging canoe, just picked up his ashes and is sailing with them on a final voyage for him during the current training mission. And if you're interested in Polynesian navigation, please check out the Polynesian Voyaging Society's website, PBS Hawaii. They have great information. They usually have blogs from their sailings, and sometimes there's live video or recorded videos from the ships. As the eclipse is getting more total, you're starting to see a little bit of that coppery color. It's looking quite nice, and you can see in the eclipse portion with the camera, you can still see the various lunar features. Again, if you're just joining us, we're the University of Hawaii's Institute for Astronomy. My name is Roy Gal. I'm one of the astronomers here. And Alex Djerba, an amateur astronomer, is here running the telescope, donating his time and expertise for actually taking the imaging. And my colleagues Zach and Carolyn are helping answer questions in the chat on YouTube. I'm trying to pay attention to them as well. So please go ahead and ask us questions about the eclipse, about the observatories here, about astronomy, anything you'd like, and we'll be happy to answer them. So the images that you're seeing are from a Canon DSLR digital camera attached to a small refractor telescope, 840 millimeter focal length. And then it's just feeding the images to this image capture software, and then we're sharing it to you on YouTube. So it's not a very complicated setup at all. The hardest part was getting the telescope aligned out here on the street so that it would track the moon nicely rather than us having to follow it along by hand the whole night. We're very happy to be able to provide this live stream, and we're glad it cleared up. There were some clouds earlier in the day, so I was worried that we were going to be out of luck. There are some other feeds available. There's a view from a top Mauna Kea from a wide field camera, but it doesn't show as much detail. Now that I said that, there's a cloud coming close to the moon, so we might lose it here in a little bit, and then it should clear up again. Only a couple of patchy clouds. We do have a little bit of a cloud coming, but after that cloud, it's clear. So you might see it dim for a few minutes while the cloud passes by. Yeah, someone's commenting that we're all looking at the same moon at the same time. Well, it's different times in different parts of the world, but yeah, we're all enjoying this view. And we're glad people can join us from everywhere. Perhaps one nice outcome of this pandemic is that we've all learned to live together virtually. I was teaching virtually, and I had students who didn't even come to Hawaii this semester and were back home, for instance, in the Czech Republic with their family, and I was still able to teach them. And while a teaching assistant was in California, and yet we were all able to work together. It would be nice to be all back together. We're going to be reopening our campus in the fall. Actually, campus is reopening June 1st, but we should be having classes on in person in the fall, which will be a nice return to something of normalcy. And we hope everyone out there is staying safe and healthy. Someone asked about the telescope. It's a small refractor telescope with a 140 millimeter focal length and just a Canon DSLR attached to it. So it's nothing fancy or expensive. If you want to know a brand name, it's an Astrotech 65. So this live feed is coming to you direct from St. Louis Heights in Honolulu. It's just a residential neighborhood. We're actually in my driveway where there is power and internet. So we did not go any place that is extremely dark since the moon is quite bright. And here's a nice image where you can see the dark parts of the moon. The term for those is the mare, which is Latin for seas. They look like oceans, but they're just areas where there's been more recent geologic activity, so the craters have been wiped out. Someone's asking, why haven't we gone back to the moon? Yep. The moon is not that geologically interesting either. We have samples of it here. Some people have considered that returning to the moon would be a stepping stone for traveling to Mars. The other answer is that robotic exploration is cheaper and safer than human exploration now. I mean, back in the 60s when we were first traveling to the moon, we didn't have the robotic and computational capabilities, and now we have car-sized rovers landing on Mars and deploying autonomous helicopters for a fraction of the cost of sending a human to the moon, to Mars. So robotic exploration is definitely the safer and cheaper way to go. I know people have done experiments looking at the reflected light from the moon during eclipses to see what the spectrum of Earth's atmosphere might look like from an outside perspective to give us an idea of what an extrasolar planet's atmosphere would look like to us if we were observing it. So someone asked about the characteristics of the moonlight. So the reason the moon is looking coppery colored is that we have where even though the moon is in Earth's shadow, so you would normally think it's therefore should just be dark, like your shadow on the ground, the sunlight is passing through Earth's atmosphere, and the red light from the sun is refracted or bent by the atmosphere. That's why at sunset, the horizon looks red even after the sun is down. That same bending of the red light, the refracting of the red light that gives us the red horizon is what's giving us the coppery colored moon. So if you imagine you're looking at the moon and the sun is behind Earth, as seen from the moon, and the Earth is blocking the sun, but the red light is going through Earth's atmosphere and being bent back onto the moon, whereas the blue light is scattered in all the directions by Earth's atmosphere. So that red light that's refracted through our atmosphere is what's still illuminating the moon. And now we're really seeing that coppery color. This is actually a really nice blood moon. Someone asked us how we help with NASA. I see some answers there. And on Mauna Kea, the NASA Infrared Telescope Facility, IRTF, is actually operated by the UH Institute for Astronomy under contract with NASA. So the director and associate director and telescope staff are all our employees. So NASA pays us to run that telescope for them. And I'm glad for those of you who have cloudy skies elsewhere on Oahu or around the world that we've got clear skies and are able to see this. I've just gone to take a naked eye view of the eclipse. And actually, I cannot with my eyes see very much of the red color. The part of the moon that's still illuminated is so much brighter that it makes it hard for my eyes to see the red color. So it's nice with a little bit longer exposure time on the camera and through the telescope that even though the bright part of the moon is overexposed, we can really see the coppery color on the eclipsed part of the moon. Yeah, if the Earth's atmosphere had a lot of clouds in it, then less of that refracted light would make it through and we would get a much grayer looking eclipse. So we're lucky to have a large part of the Earth's atmosphere through which the sun is shining, being clear and not super cloudy. So someone asked about the differences between the near and far sides of the moon. So we never see the far side unless we send a spacecraft to it. There's difference in the number of craters, but geologically there's the chemical makeup, the mineral makeup of the moon is the same. If you look at the far side of the moon, it has very few mare very few of these dark, large areas, and it's much more covered in craters. And of course, we had no idea what the far side of the moon looked like until we were able to send spacecraft to take pictures of it. It's actually remarkable to think of all the things we did not know about until the past few decades or the past century. Today, we take it for granted that, oh, we live in a big galaxy, the Milky Way, made of hundreds of billions of stars, and that there's hundreds of billions of galaxies like that. But roughly a century ago, we did not know that. It was a debate over whether the tiny fuzzy things that people saw in the sky were part of our own galaxy or or at that time called island universes, other galaxies like our own, just far away. So we've come a long way, and we have certainly a long way to go. Just as we're uh, approaching totality, we're going to have to restart the camera here. So we'll be offline with the images for a minute. We'll be back in a minute or two with the images as we get to totality. Someone wrote, "Good morning from the USA." We're here in Hawaii in the USA too, and it is the wee hours of the morning, almost 1 o'clock. The orientation of the moon might look different in the images because telescopes and cameras can flip images around and into place. This also depends how it's displayed in the viewer. Okay, we are back. Boy, that is one very red looking moon. It's quite fantastic. I think it's the reddest eclipse I've seen, although maybe it's the camera. For those just joining us, welcome to this live stream of the Lunar Eclipse from Honolulu, Hawaii, hosted by the University of Hawaii's Institute for Astronomy. My name is Roy Gall. I'm an astronomer here. Alex Djerba, an amateur astronomer, is providing us this feed with his telescope and camera. And my colleagues Zach and Carolyn are helping answer questions on our YouTube feed. So please feel to ask questions in the chat in YouTube, and we'll try to answer them as best as we can. I'll grab some of them and answer them verbally, and others might get typed answers. It is definitely looking really beautiful. You can really see the very red color on the totally darkened side of the moon. So we are 14 minutes away from the beginning of totality. Sorry that you're clouded out in Kailua. We're quite lucky now. About half my sky here is cloudy, but luckily it's in the western half and not the eastern half where the moon is. Hopefully it stays clear for the next half hour or an hour or so. And again, we're just using a DSLR camera attached to a small refracting telescope. Oh, wow. Observatories on the mainland clouded out. There is a view from a wide field camera atop Mauna Kea, a Subaru telescope, but you can't tell very much from that because the moon is just a small part of the image. And I think Keck Observatory is providing some live feeds. It looks beautiful here right now. About 10 minutes from the beginning of totality. For those of you trying to observe the eclipse and getting clouded out, of course, that's one reason why we put observatories on mountaintops is often we're above the clouds, but we also try to pick sites that have less cloud cover throughout the year. But if you happen to be assigned a night of telescope time and it's cloudy, then you're usually just out of luck. Many observatories work on a system where you propose for telescope time, and if you're given that time, you're awarded that time by a committee that decides which projects are worthwhile. Then you're given a specific night or nights of time, depending on when your objects are visible. And if it's cloudy on your night, then too bad, you're out of luck. Some telescopes work on a queue schedule where they observe from all the lists of targets that people have submitted in order of scientific priority. But even there in a bad semester, if you've got lots of nights of clouds, then less targets get observed. So we are at the mercy of the weather here on Earth. Yeah, if you're in Hawaii and you have clear skies, have a step away from your laptop or computer screen or TV screen, wherever you're viewing it. Go outside and take a look up in the sky and enjoy the natural view. Grab a pair of binoculars if you want. You'll see more details on the moon. And especially as we approach totality, the red color will be more obvious to your naked eye as the bright edge gets into shadow as well. remove the mouse pointer. Thanks for that. If you go outside and look with your eyes, the moon actually looks quite ball-shaped, much more than when it's totally illuminated. You can get a really sense of it being a three-dimensional object. And if you see some bright stars around the moon, that's the constellation Scorpius. So the moon is nicely cradled by the constellation Scorpius tonight. This eclipse is not visible from Louisiana. It's only over the Pacific. There will be an eclipse in November 18th to 19th that's almost total that you'll be able to see in Louisiana, something like 2 or 3 in the morning. If you're interested in seeing when partial or total lunar eclipses or solar eclipses will be visible in your part of the world, I highly recommend timeanddate.com. They have links to eclipses. There's maps for future eclipses. You can put in which city or country you're in, and it'll list what eclipses are visible in the future. And there's even a little link to see all the ones that you could see up to the year 2199, should you live that long. This stream is from Honolulu, Hawaii. So if my sky map here is correct, that little star that you see in this image at something like, 5 o'clock, 6 o'clock is HD 145809, in magnitude 6.7 star in Scorpius. I'm using an app called Sky Guide on my phone to see that. There are a number of really good iPhone and iOS and Android apps for free or for a couple of dollars that you can use. There's an excellent computer app called Stellarium that you can use on most operating systems to see what's up in the sky. Sorry for those of you in Australia where it's freezing cold. We're enjoying something like 75 degrees outside right now. The maximum depth of totality will be at 118 here, so totality will start in 4 minutes. Well, I'm glad we decided to stay up late and do this here. And we're lucky to have a nice cloudless view right now. Someone asked what app I'm using. I used Sky Guide. There's another app called Planets. I find Sky Guide pretty good, but you can just go to the Android or iOS App Store and look for planetarium software and see what people have to say in the reviews. The one that you can use on computers doesn't work on phones. It's called Stellarium, but it works on PCs, Macs, Linux, Unix computers, and it's free. It's pretty powerful. We actually use it for teaching some of our astronomy labs here. Yep, the imaging device is a Canon DSLR camera, and it is attached to an Astrotech AT65 refracting telescope with an 840 millimeter focal length. Nothing particularly fancy. You could do this with any small telescope or even a large telephoto lens attached to a DSLR camera. Aloha to all of you around the world, whether you're on the uh, mainland or on the other side of the planet in India or Australia. So as you can see, as we're approaching totality, it's still darker on one side of the moon and brighter on the other. So even though the moon will be entirely in Earth's shadow in a minute or so, it won't be as dark as it gets until 118. That's when it's going to be in the center, or as close as it gets to the center of Earth's shadow. And this time, even though we're getting a total eclipse, we're just at the edge of Earth's shadow. So there are lunar eclipses that go through more of Earth's shadow than this one, and will have longer totality. That is a fantastic coppery color as seen through the camera. Yeah, really beautiful view. As I was saying, if you're in Honolulu, then a mere 11 hours from now, you can go out and observe Lahaina noon, and the sun will be directly overhead at 12:29 in the afternoon today. And then the shadows for things in the ground like lampposts and bollards and signposts will all disappear. You'll have no shadow. Looks quite strange. So we get a nice astronomical double feature. That kind of thing only happens in the tropics. So this stream is being provided by the University of Hawaii Institute for Astronomy. My name is Roy Gal. I'm an astronomer here. My colleagues Zach Claytor and Carolyn Keiichi are helping answer questions on the chat, and Alex Tierba is our telescope and camera operator. Wow, from the Cook Islands, we've got people from all over the world joining us. This is fantastic to see. Thank you all for joining us. If you didn't get to see this eclipse in person and you're on the mainland US, the eclipse on the evening of November 18th, early morning of November 19th is about 97% almost total, and that goes over most of the mainland US. So we are in totality now. We're 4 minutes from maximum, and we'll be exiting totality at about 1:25 our time, so about 10 minutes from now. And we'll hang on for some time after that for people joining us late or who want to watch as the moon emerges from Earth's shadow. But we're not going to stay on later than 2 because we need to sleep also. So as people are pointing out, one edge of the moon still looks relatively bright, and that's true naked eye as well. And that's because this eclipse, even though it is total, the moon is completely in Earth's shadow. It's just barely inside Earth's shadow. So we're not getting a super dark eclipse on the whole part of the moon. The website I was mentioning, timeanddate.com, actually has very nice animations that show how the moon passes through Earth's shadow, and you see that we're just grazing the inside part of Earth's shadow. Lunar eclipses are a common occurrence. We just don't see them in the same places all the time. Depends what part of Earth is rotated towards the moon and away from the sun. So for those of you who are on a daytime part of the Earth now, you're not seeing the eclipse. Throughout history, people have thought that solar or lunar eclipses were the portents of things to come, but they're quite common and totally predictable events. So we can predict to within seconds when totality is and what portion of the moon will be eclipsed. So we understand the orbits and the positions of objects in our solar system, the Earth, the sun, and the moon, to high precision. Yay, science. So we're actually about a minute away from the deepest part of the eclipse, and we'll be in the total eclipse till about 1:25, and then the moon will slowly move out of Earth's shadow, and we'll see the other side of the moon getting brighter with time. So if you're in Honolulu, Lahaina noon will be at 12:29 in the afternoon. In other parts of Hawaii, like on the Big Island, Lahaina noon was a few days ago. So it depends exactly where you are. The Bishop Museum has a very nice Lahaina Noon webpage that tells you the time and date of Lahaina Noon in various places in Hawaii. And actually, the term Lahaina Noon was coined by, I don't remember the name of the person, but the Bishop Museum hosted a contest for naming that astronomical event in, I believe it was in 1990. And the name Lahaina Noon was chosen as the winner. So before that, we didn't use that term. And you might think that Lahaina Noon refers to the Lahaina, the city on Maui, but La is the Hawaiian word for the sun, and Lahaina translates into something like the mean sun or the cruel sun. But Bishop Museum does not tell me who coined the term Lahaina Noon, just that it was the winning term in that contest in 1990. So if you're out there and you're the person who came up with that name, then you can let us know. Yeah, I'm glad we have clear skies. I hear that many of the other live feeds are being dogged by clouds. We're pretty lucky. I've got some clouds here in the west, but they're staying away from our view of the moon for the most part. If you happen to be in Hawaii and have a clear view of the eastern horizon, then you'll see Saturn rising, and then shortly after that, Jupiter. And if you see a relatively bright kind of orange star high up in the sky, that's Arcturus. The Hawaiian name for that star is Hokulea, like the voyaging canoe, a very important star for Polynesian navigation. And Hokulea and its sister vessel Hikianalia are actually voyaging right now, training a new generation of navigators. So someone asked about asteroids hitting the moon. It does happen. They're typically small. NASA actually has a program to monitor for those, but they're quite rare and they're quite small. You can Google NASA lunar impact monitoring, and they have a description of their program and what the impact rates are. Even though we see a lot of impact craters on the moon is not geologically active and has no atmosphere. So the fact that we see that many craters is just the result of millennia of impacts, so that on any given day, the likelihood of an impact is extremely small. All right, we're going to be emerging from totality here in a minute. So we'll slowly start to see portions of the moon brightening up. What a beautiful copper color we see from the camera view. When I go and look at it naked eye, I can see that it's reddish, but it's not quite as brilliant as it is in the telescopic view. So I saw someone ask, what can we even see at the distances of the moon? Obviously, with telescopes, we can see a lot, and we can see a lot of detail. In astronomy, we use angular measures of degrees, and then we divide a degree into 60 minutes of arc. And then each minute of arc we divide into 60 arc seconds. So an arc second is a tiny angular measure. It's the size of a dime as seen from about 2.5 miles away. So that's a teeny tiny angle. And our telescopes, like those on Mauna Kea and Haleakala and elsewhere, have resolutions that are much better than that. So we can discern details in the sky that are smaller than a dime seen a few miles away. So you could imagine taking the Keck telescope and pointing it on Earth and ignoring Earth's atmosphere, it would be able to easily make out the image on a dime 3 or 4 miles away. In fact, if there was no atmosphere, it could easily read the text on the dime at that distance. But we're not using a big telescope like that. This is just a small refracting telescope with a DSLR camera. The moon on the sky is about half a degree across, so much larger than the angles we're talking about. Yeah, someone says it was never total. In fact, it is a total eclipse, but just barely. And that light that we see on it is just the light that's refracted through Earth's atmosphere, which is why it's reddish looking. If you go to the timeanddate.com, it shows that we just graze fully inside of Earth's shadow. So that side that's illuminated is the part that's right close to the edge of Earth's shadow. But our eyes are really good at adjusting to different levels of light. And so even though that part of the moon is quite a bit darkened, it still looks bright to our eyes. If you're joining us, we're streaming this from Honolulu, Hawaii, near the University of Hawaii at Manoa. My name is Roy Gal. I'm an astronomer at the Institute for Astronomy and handle our public outreach events. My colleagues Zach and Carolyn are staffing the keyboards, answering questions on the YouTube chat. And the most important person here is Alex Dzierba, who you don't hear, but it's his telescope and camera actually providing the feed. So a huge mahalo to Alex for doing this for us. He is not a professional astronomer. He does this for fun. So he's the coolest person in the room. And we're glad you can all join us and enjoy this view from around the world. You can check us out on our Facebook page and our Twitter feed. They're all UHIFA, University of Hawaii Institute for Astronomy, and we post news stories, astronomical events, public talks. We're going to be having a public talk by our intern director, Karen Meach, coming up in June, talking about Oumuamua, the object that passed through our solar system not that long ago, but that came from another solar system that a specific astronomer, who I shall not name, claims is an alien spacecraft, but it is not. We have conclusive evidence. He's just ignoring it. So we have already passed maximum eclipse and we are on our way out of totality. So totality ended at 126. So the moon appears red because the light that's hitting the moon, even though the moon is in Earth's shadow, the sunlight, some of the sunlight is passing through Earth's atmosphere and being refracted or bent by the atmosphere and still landing on the moon. Just like at sunset, right? The sun goes down below the horizon. And even though you can't see the sun, the horizon looks red. And that's because the atmosphere bends the red light from the sun and it ends up in your eyeballs, whereas the blue light from the sun gets scattered all over the place. So the blue light from the sun that's passing through Earth's atmosphere gets scattered in every direction, but the red light, some of it is being bent and landing on the moon, even though the moon is in Earth's shadow. And that's what casts that coppery reddish color. And so if Earth was heavily covered in clouds right now, then we would not get such a red moon because the clouds would prevent that red light from making it through. But we must have relatively clear skies across a significant part of Earth so that we're actually getting a really, really nice deep red moon for this eclipse. It's our pleasure to provide this. It's great to bring a little bit of astronomy to people in the world. We know everyone likes looking up and wondering what's out there. And we're always learning new things every day. We write textbooks, but those textbooks get updated every year, and that's because we're always learning new things. If you keep your eyes on the news, there'll be an interesting news story about planets around other stars coming out tomorrow from us, Caltech, and the University of California, but I can't tell you what the news story is yet. So just a tease. It'll be out at 9 a.m. Pacific time. Only a couple hours from now. Our pleasure. Thank you for joining us. We're glad we can provide this. We're glad the weather is cooperating and the telescope is cooperating. we're just playing around with the exposure settings as the brightness of the moon is changing with more of the sunlight coming on it. So someone's asking when this eclipse ends. The eclipse is 100% done in about 2.5 hours. The totality has ended. The partial eclipse ends at 2:52 in the morning our time, which is an hour and 20 minutes from now, roughly. And after that, the moon is only in Earth's penumbra, which is sort of outer part of Earth's shadow, until about 4 in the morning. But that's not that visible to your naked eye. So we're not going to stay up that long. We're probably going to call it quits here in about 20 minutes and get a couple hours of sleep before we go to work in the morning, or before I have to take my kids to school. So we've passed totality, so we saw as much coverage in red as we were going to see at around 1:18, and we are viewing it here in Honolulu, Hawaii. This is very real. I could take a picture of Alex sitting here with his little telescope in my driveway, but then you lose the feed of the moon. Someone asked about two moons with different orbits. That's a really interesting question. It depends on the angles of those orbits and their sizes. So as long as those orbits cross the ecliptic at regular intervals, which they certainly would, then you could get any combinations of eclipses. Probably be pretty rare to get both moons lined up. They would be eclipsing each other. If you want to really puzzle yourself about geometry, then you could think about solar systems that have two suns, like Tatooine does in Star Wars. We have found systems like that where there's planets orbiting binary stars. And there you can have the stars eclipsing each other. You could have all kinds of interesting configurations. The planets go around the two stars. So the two stars are in the middle and the planets are going around in a big orbit around the two stars. Someone asked about the shadow and calculating Earth's diameter. The way the ancient Greeks actually calculated Earth's diameter was by using sticks and shadows on the Earth. And you can look up Eratosthenes and his method for looking up the circumference of calculating the circumference of the Earth. So many thousands of years ago, the ancient Greeks already had simple evidence for the Earth being a sphere. So here's the name of that Greek astronomer. So Eratosthenes did an experiment. He's looking at the lengths of shadows at different places, or the timing of shadows, and they estimated the circumference of the Earth pretty accurately, given that they were using just sticks and shadows and had to measure distances from one place to the other using their feet, basically. So understanding basic trigonometry, which the Greeks did, allowed them to calculate the size of the Earth and understand that it was a sphere many thousands of years ago. So discussions of today about the Earth not being a sphere are pretty strange, given that there are many simple experiments that show that we live on a ball. And you certainly do not need a telescope to enjoy much of the astronomical sights that are out there. With a relatively simple pair of binoculars, like a 10 by 50 binoculars, you can see lots of detail on the moon. If you have a steady hand or a tripod that you can mount your binoculars to, you can see some of the moons of Jupiter and Saturn's rings. And today you can get motorized, go-to computer-controlled telescopes for a few $100s. You don't need a big one, especially in a light-polluted place like Honolulu, to be able to enjoy some of the sites like some of the globular clusters and open clusters that you can see. Planets, you can see the phases of Venus, enjoy Mars. So now you can see it's brightening up as we are emerging from totality. Still get that really nice red color. The moon will not look similar tomorrow. There will be no eclipse tomorrow. You need a really good alignment of the Earth, the sun, and the moon in a straight line. And because moon's orbit is tilted relative to Earth's orbit around the sun, from one day to the next, the moon is not lined up correctly to get an eclipse. The next almost total eclipse is in November of this year. Yeah, we're going to end this stream around 2 o'clock in the morning, our time. You're very welcome for the stream. A good night or a good morning, good evening to wherever you are on Earth. I see someone saying that their students sign on in 20 minutes. Maybe we can hang out for a couple more minutes so they can see something. The video, I believe, is recorded on YouTube and will remain up there. So I know the video of the conjunction that we did back in 2020 is available there. You can find us where you're viewing us here at UHIFA on YouTube. That's what we are on Facebook and Twitter as well. And you can just Google University of Hawaii Institute for Astronomy and find us, our website. Our website is, I will put it in here, is ifa.hawaii.edu. And we are at UHIFA on social media. So some people ask, what's the longest lunar eclipse? So the Earth's shadow is much larger than the diameter of the moon. And this evening or this morning, we're just skirting the edge of Earth's shadow. So we only had about 14 minutes of totality. But if you go right through the middle of Earth's shadow, you can have over an hour and a half of totality. The longest lunar eclipse that's coming up in any reasonable time is going to be in the year 2264, when none of us will be around to witness it. And that one will be almost 2 hours. That's going to be a dark eclipse, I imagine, if humans are still around to see it. We're doing this from Honolulu, Hawaii. So the next solar eclipse is in June 10th. It's an annular eclipse, which means that uh, you have a ring of light around the moon during the eclipse, so that the moon is a little bit farther from Earth, and therefore it looks smaller on the sky, and so it doesn't block 100% of the sun. We will have a total solar eclipse in 2024 that we'll be able to see in most of the United States. If you've ever seen a solar eclipse, you know it's a pretty amazing event. I went to Oregon to see the one a couple years ago. That was pretty incredible. That was my first eclipse. We have astronomers who actually study the sun during eclipses because you can see the outer parts of the sun. One of our colleagues, Shadia Habal, travels around the world catching eclipses, and really amazing images they have with special telescopes and filters showing the material streaming off of the sun. It's many times the radius of the sun. Pretty incredible. And you can only study those portions of the sun during eclipses, otherwise the sun is too bright, and spacecraft that observe the sun can't see as close to the sun as you can during an eclipse. So their views are pretty spectacular. Her team is called the Solar Wind Sherpas, and I'll just put their website up here because they have amazing images of the sun. Someone asked where the 2024 solar eclipse would be visible. There are maps of the path of totality on timeanddate.com. So it starts, it crosses over Mexico and then sort of over the eastern central United States and up towards sort of the area of Maine and the Canadian border. Some places that I'll see it: Cleveland, Rochester, Montreal, Indianapolis, Toledo, Little Rock, Dallas. So lots of significant cities will see at least part of the totality.
How the totality goes through my father's property.
Oh.
Really close to.
So someone's asking if most tracking telescopes track this well. If you buy a decent go-to telescope and you align it correctly, so before we started this broadcast, Alex spent some time aligning his telescope so that it was leveled and knew where north was and things like that, then it'll track well. If you don't align it correctly, then you're not going to get good tracking. If you're looking up at the sky, the moon was near the constellation Scorpius. So if you see some bright stars near the moon, then you're seeing the constellation Scorpius. So we'll hang out here for another 10 or 15 minutes and then we're going to pack it up. We hope you'll check out our website, ifa.hawaii.edu, for news stories. We are a large academic astronomy unit at the University of Hawaii. We have 45 or so PhD astronomers, 30 to 40 graduate students. We run observatories on Mauna Kea and Haleakala and participate in space missions. We have an undergraduate and a graduate program. So if you're thinking about a career in astronomy or just want to take some astronomy classes, you can come here to the University of Hawaii at Manoa and take classes from some of us. Someone is asking about Jupiter and Saturn. So Saturn is rising first. So Saturn will be a little bit higher in the sky than Jupiter, and Jupiter is the brighter one, which is rising a little bit later. And they're rising almost to due east. They should not be very high in the sky yet. And the bright oranger star high up in the sky is Arcturus or Hokulea. Someone's asking that they went at 4:11 Pacific Standard Time. I don't know where you are, Jenny Chen, so it depends where you are on Earth, but California did not have a view of totality because California is not facing the right way to see the total eclipse. Everyone's welcome for the stream and the commentary. I'm glad you're enjoying it, and I'm glad we can answer some of your questions. Yeah, someone's asking about the stars that are close to the moon. Scorpio looks kind of like a backwards curved check mark to me. That's probably a bad description, but it's the best I can do off the top of my head. And the moon is kind of cradled by the check mark of Scorpio. We don't have a big enough field of view here to show you all the stars with this setup. So here in Hawaii, Jupiter and Saturn are rising now. Depending on what's on your horizon, if there's mountains or something in the way, you won't see them. You have to look towards the eastern horizon. I can't see them. My horizon is blocked by my eastern horizon is blocked by mountains. But there are a lot of apps you can get on your phone or on your computer that will show you what's visible right now. A lot of great phone apps. You just, if you have a smartphone, an Android or an iOS phone, you can just point to somewhere in the sky and it'll show you what's up. Google has a great program, Google Sky. If you want to understand the geometry of lunar and solar eclipses, you can just Google lunar eclipse geometry and you'll find lots of videos that show you what's happening and why you don't get them all the time. If the orbit of the moon was exactly in the same plane as the orbit of the Earth is around the sun, then we would get an eclipse every month. We would get a solar eclipse when the moon was between the sun and the Earth. That's when we have new moon. The moon is backlit by the sun, so we see the dark part of the moon. The moon's not lit for us. That's new moon. And if it was lined up with the sun every time, we would get a solar eclipse every month at new moon, and we would get a lunar eclipse every month at full moon. But because the orbit of the moon is tilted relative to Earth's orbit, sometimes the moon is a little bit above the sun or a little bit below the sun compared to Earth, and so we don't get an eclipse. The place where the moon's orbit intersects the Earth's orbit is called a node. And in order to get an eclipse, that node has to occur when the moon, the Earth, and the sun are in a straight line relative to each other, not when the moon is someplace else in its orbit around the Earth. Shout out to my friends Chris and Ryan, who I see are hanging on here in the early morning hours. I'm glad some of you around the world are getting a clear view like we are, and I'm glad those of you who got cloudy skies or don't get the full lunar eclipse where you are were able to join us. Someone asking what the supermoon is. So the orbit of the moon around the Earth is not a perfect circle. It's an ellipse. It's a little bit elongated. So sometimes the moon gets closer and farther from the Earth in its orbit. When the moon is closest to us, it's called perigee. That means closest point to Earth. When it's farthest, it's called apogee. So when the moon is closer to Earth, it looks a little bit bigger, and we call that a supermoon. So actually, perigee was about a day ago, and so the moon is really close to Earth, comparatively speaking. It's only a few percent difference, 7% closer, plus 7% farther away, or minus 7% closer. So it's not a huge difference in distance, but it is noticeable. And so the moon does look bigger at perigee than it does at apogee by quite a bit. Yeah, we're now well past totality. Totality ended a little more than half an hour ago. And now you can see that the copper color is not so visible anymore. And we're probably going to end this feed in a few minutes. It'll be available on our YouTube channel here to rewatch. We have videos from some of our students talking about their research, and some talks about astronomy. We'll be populating it with more videos over the next few months from our past public presentations. And again, you can keep up with events going on here, astronomy news, public events that we'll start having again as COVID decreases at our website, ifa.hawaii.edu, and our Twitter and Facebook, UHIFA. So I think we're going to get ready to go to sleep. I'll get my 4 hours of sleep before it's time to wake up the kids and take them to school. I don't know what time Alex has to go to work. Alex is lucky. He tells me he got the day off, so he can stay up, but I'm not. So again, thank you all for joining us. We're the University of Hawaii Institute for Astronomy. My name is Roy Gal. My colleagues Carolyn and Zach helping out on answering questions, and Alex Dierba providing the feed from here in Honolulu, Hawaii, where we're lucky to have clear skies and a great view of this total lunar eclipse, the super flower blood moon eclipse. Flower moon because it's May when flowers bloom. That's just a colloquial name for the full moon in May. Super because the moon was closer to Earth, was close to perigee, so it looks bigger. And a blood moon because it looks red during totality. That's a relatively new term. Everyone uses it now. It's pretty amazing how quickly things come into our language. All right, I'm gonna turn off our live stream here, and that'll be the end of our broadcast from Hawaii. Thank you again for joining us.